Hey guys, Ms. Gosling here. In this video, we are going to talk about Cepheid variables. By the end of the video, you will be able to describe the reason for variation for Cepheid variables and the ways in which we use Cepheid variables to better understand our universe. So with that, let's go ahead and get started. So our understandings for this are Cepheid variables. So essentially, you should have a definition for the word Cepheid variable at the end of this, and you should be able to describe the reason for the variation of Cepheid variables, again, by the end of this video. So a Cepheid variable is a star with a luminosity that varies over a measurable and consistent period of time. Now, when I downloaded these GIFs from my slideshow onto the app I'm using to make this video, you can see the GIFs did not really stay as GIFs. They are, in fact, just pictures. So on Schoology, what I've done is I've added a link to the slideshow where the GIFs are very obvious. So what you should see is that that picture on the left is blinking at a very consistent rate. In fact, you can see the star getting bigger and smaller, expanding and contracting, and we can also see it getting, therefore, brighter and less bright. So that is an animation of what a Cepheid variable looks like. On the right, you can actually see some specific Cepheid variables. Now, I must tell you that that GIF on the right is very much sped up. A Cepheid variable actually has a period between 2 and 40 days. So obviously, both of these pictures are, both of these GIFs are expanding and contracting, getting brighter and less bright with a larger period, or with a much smaller period, and that you can see them getting brighter and less bright. So Cepheid variables, we have to measure their brightness over time. By setting up, for example, a telescope to track the Cepheid variable, and to measure its brightness every single day over a period of 40 or 80 or 100 days. So that way we can see that its period is in fact getting brighter, that its luminosity is varying over a very measurable and consistent period of time. So Cepheid variables pulsate because they have a periodic expansion and contraction of the surface layers of the star. So again, if you go back to the GIFs that I posted, in that picture on the left, the star isn't just getting brighter or dimmer. What it's doing is it is expanding and contracting. And so when we talk about the expansion and contraction of the surface layers, that's what we mean. The star is physically getting bigger and smaller. And as we know, luminosity is proportional to radius, so as radius increases, luminosity will as well. And so as the star gets bigger and smaller, we will also see it get brighter and dimmer. So the other thing that's important to know is that when the Cepheid variable expands and contracts, the size, temperature, and transparency of the star changes as the surface layers change, which is what causes the brightness to vary. Now, my recommendation for y'all is that you focus on size and temperature, because we have talked about how size and temperature affect luminosity, and so I think that those are a lot more memorable than transparency. The transparency does change, but again, we have not really discussed the relationship between transparency and luminosity. It's outside the scope of this class, so please, again, focus on size and temperature. So let's take an example of an IB style question. So eta aquili A is a Cepheid variable. Explain why the brightness of eta aquili A varies. So what I'm going to ask you to do is take a moment. I want you to look at the definition of a Cepheid variable, look at your notes from the previous slide, and see if you can pause the video and come up with an answer to this question. Now, before you pause, really quickly, please note this question is 3 marks. Remember that means that you need to make 3 points in your answer for the question. Okay, now pause the video. Okay, so here we have an example of the mark scheme for this problem. I figured since this is an explain question, not a math question, it made more sense for me to go through the mark scheme, which again is the answer key that your IB graders use when they are grading your test. I thought it'd be helpful for us to go through it together so you could see a little more clearly what some of these mark schemes look like. Okay, so this question is 3 marks. And if you look at the mark scheme, there are 4 things listed. So a reference to change in size, temperature, a reference to the periodicity of the motion of the change in luminosity of the star, and a reference to transparency or opaqueness. This is 3 marks, so you only need 3 of those 4 things. Now, again, my recommendation, and I hope what you guys mentioned, is that the size of the star changes, that its temperature changes, and that both size and temperature are changing periodically, so that they are changing with a consistent period. You may have mentioned transparency as well, or the opposite of transparency, which is opaqueness, but again, those first 3 are really all that you need. So why is all this useful? So the thing that is really, really useful about Cepheid variables is that the period of a Cepheid variable can be graphed. So we can very easily figure out by measuring its apparent brightness over a period of time, the period over which that brightness changes by, for example, measuring the amount of time from one peak to the next. This is useful because the period of the Cepheid variable is directly related to its luminosity. So as a result, if we know period, we know luminosity. And remember, luminosity is how bright the star is, or how much power the star is radiating, not how bright it appears to be to our human eye here on Earth. And remember, if we know both brightness and luminosity, we can then calculate distance from Earth, yes? Because remember, brightness, B, is equal to luminosity over 4 pi times the distance between Earth and the star squared. So if we know brightness and luminosity, we can find our distance, D. Since with Cepheid variables, if we know period, we can find luminosity, we therefore know both luminosity and brightness, and we can use that Cepheid variable to navigate our universe. We call this a standard candle, and that's an object in the universe with a known luminosity because standard candles allow us to figure out how far away they are from us. So again, for Cepheid variables, we use period, T, to find luminosity, L, because there is a known relationship between luminosity and period. If we know luminosity, we also know brightness, which of course we can measure for any star in the night sky. We can therefore use our luminosity equation, our brightness equation, to calculate the distance from Earth. As a result, if we know something is a Cepheid variable, we know how far away it is, and we can use it to help us navigate the universe a little bit more clearly. And again, we call objects like Cepheid variables standard candles because they have known luminosity. So let's take a look at a second example. Explain how Cepheid variables are used to determine distances. And this is another explain question, so please pause the video, see if you can come up with an answer to this question on your own, and then together we'll go through the mark scheme. Okay, so let's look at the mark scheme. So for a Cepheid variable, the peak luminosity, so luminosity depends on period. Or you could say something like more luminous Cepheid variables have a greater period. Again, you don't need to know that you don't need to know that specific relationship. This first line is all we need. So if we measure apparent brightness, we can determine distance. Or instead of saying that, you could just mention the equation for brightness. So hopefully you mentioned luminosity depends on period, or we can use period to determine luminosity, and then we can use luminosity and brightness together to figure out distance. You'll notice this question has some letters at the bottom, OWTTE. That means other words to that effect. And what other words to that effect means is that the grader has the choice or has the freedom to look at your answer to this question and see if your answer gets the gist of what this mark scheme says. If it does, they can choose to give you credit. If a question doesn't have other words to that effect on it, what that means is you are expected to have the specific phraseology that is listed in the mark scheme. And if you don't, it's wrong, even if you're on the right track. So please make sure you are very careful with things like definitions to make sure you have the exact right language. So with that, let's talk takeaways. So first of all, Cepheid variables are stars whose luminosity varies with a constant period. And perhaps it would be better to, instead of saying luminosity, let's write brightness, because we are figuring out that a star is a Cepheid variable by measuring its brightness. Next, the period and luminosity of Cepheid variables are directly related. So the longer the period at which it blinks, the more luminous the star. And because luminosity and period are directly related, we can use period to find luminosity. Knowing both brightness and luminosity, we can determine the distance between us and a Cepheid variable, a known Cepheid variable. And because of this, we call Cepheid variables standard candles. So there you are. Here is everything you need to know about Cepheid variable stars. Go ahead and see if you can find some yourself. Best of luck and happy searching.